in example 2, we don't have a picture of a parabola, but we have the inequality itself that we are trying to solve, okay? So, like I said, we are approaching solving quadratic inequalities by graphing and looking and studying the parabola associated with the quadratic inequality, okay? So that's what we're going to do here, okay? We have the inequality itself. We are going to graph the corresponding parabola and then analyze it, okay? Just so you know, the goal in solving an inequality like this, what you're actually trying to do is you are trying to find every x value that makes this a true statement. Okay, so for example, if x is 0, I just picked something random. Okay, if I plug in x equals 0, I'm going to get 0 times 0 plus 1. Is that greater than 12? Well, this is going to be 0 times 1 is greater than 12. You get 0 is greater than 12. That's a false statement. Okay, so x equals 0 is not a solution. Okay, in solving this quadratic inequality, we are trying to find every single x value that is a solution, okay? And when we write all the solutions down, okay, because typically there are lots of them, that's going to form the solution set, okay? So that is ultimately what we're trying to do when we solve these quadratic inequalities, okay? Our method is just using the parabola to get there, okay? All right, so let's go ahead and work on the graph. Now, just as a heads up, you do not have to go through the long and drawn out process that we did in section 4.3. Okay, in section 4.3, we did everything. We found the vertex, we found the x-intercepts, we found the y-intercept, and we used the fact whether, the parabola opened up or down to get our graph. Okay, here, for inequality purposes, we are just drawing a very rough sketch. Okay, so what you need for your sketch, so to sketch the parabola, here's what you need. Okay, first of all, you need to see if the parabola opens up or down. And then secondly, you are going to need to find the x-intercepts. Okay, those are the only two things you need for your rough sketch. You do not need the vertex. You do not need the y-intercept. They do not matter for this. Okay, all right, so here we go. Okay, we are solving in example 2 the inequality x times x plus 1 is greater than 12. Okay, if you notice to the right, I have two boxes. One is to rewrite the inequality, and I'll talk about that in a second. And then the other box is for the solution set, which is the final answer, all the values of x that make this a true statement. Okay. All right, let's talk about what this rewrite inequality business is. Okay. I am going to have you rewrite the inequality to begin with. Okay. I want you to write it where one side is equal to 0. Okay, so if you notice, if you look at this inequality, both sides are non-zero. I want you to rearrange things. I also want you to multiply everything out so that it is in the format ax squared plus bx plus c, and then your inequality symbol, and then 0 on the other side. Okay, so here we go. Okay, we've got x times x plus 1 is greater than 12. Okay, I am going to multiply everything out. So I'm going to distribute the x on this side. I'm going to distribute to the x and to the 1. So we're going to end up with x squared plus x is greater than 12. And then, like I said, the other thing we want to do is make sure one side is 0. Okay, my recommendation to you is that you move things over so that the x squared term stays positive. Okay, so to do that here, I am going to move the 12 over. 12 is positive, so I'm going to subtract it from both sides. So my rewritten inequality is going to be x squared plus x minus 12 is greater than 0. Okay, going forward, This is the version of the inequality we are going to work with. Okay, it's in that format, ax squared plus bx plus c, your inequality symbol, and then 0 on the other side. Okay, all right, so what we're going to do now, we have to graph a parabola. Okay, you have to graph the non-zero side. That's why it's important that everything is on one side and the other side is 0, because the non-zero side becomes the parabola. Okay, so we are going to graph f of x is equal to x squared plus x minus 12. Okay, we have to graph the non-zero side. Okay, when you look at this, remember you only need two things. Does this thing open up or down? What are the x-intercepts? Okay, so here we go. The number in front of x squared here is the a value. It is positive, it's 1. So that means since a is 1, a is positive, that means the parabola opens up. Okay, now we need to go and find the x-intercepts. Okay, so to find the x-intercepts, we need to solve the corresponding equation. So where does x squared plus x minus 12 actually equal 0? Okay, this is how we're going to find our x-intercepts. We're going to take this equation and we're going to set y equal to 0. Okay, so that is exactly what I have done. Okay, remember our function here is f of x is equal to x squared plus x minus 12. F of x is the same thing as y. Okay, I've set it to 0. So this is what I need to solve to get the x-intercepts. Okay, this is a quadratic equation. You need to either factor or use the quadratic formula. Okay, this one looks okay to factor, so I'm going to try that here, but you should get the same answer if you choose to use the quadratic formula. So I'm going to break this up into x times x to get the x squared. If you're bad with factoring, you know, trial and error will work just fine for this class. Okay, I'm trying to come up with two numbers here that multiply to be negative 12 and they add up to positive 1. So I think that is going to be positive 4 and negative 3. Okay, and you can check yourself if you FOIL it back out. You're going to get x squared minus 3x plus 4x minus 12 is equal to 0. Combine like terms, you get x squared plus x minus 12 is equal to 0. So that's right. Okay, always check yourself if you're factoring, especially if you're not good at it. Okay, if you multiply it back out, you should get what you started with. Okay, so that's how this guy factors. We have two factors, the things we're multiplying together. We need to take each one, set it to 0 and solve. So we're going to take the x plus 4 and set it to 0, take the x minus 3, set it to 0 and solve. The 4 is positive, so we subtract 4 from both sides. We're going to get x is equal to negative 4. And then over here, we're going to add 3 to both sides. We get x equals 3. Okay, these are the x-intercepts. Okay, you can write them as ordered pairs if you want to. Here, the x value is negative 4, the y value is 0, and then for this one, the x value is 3, the y value is 0. Okay, so we have two pieces of information to do this rough sketch. Okay, the parabola opens up, and we know the x-intercepts. Okay, so here comes the rough sketch. Okay, all I'm going to draw is the x-axis. I'm not even going to draw a y-axis. Okay, on your x-axis, walk from left to right. Which intercept would you encounter first? Well, I would first hit the negative 4, and then later I would hit the 3. Okay, these are the x-intercepts. Okay, so that's where we cross the x-axis. Okay, and the parabola opens up. So I'm just going to draw some random parabola that goes through these two x-intercepts, and it opens up. Okay, don't care where the vertex is. Okay, it's somewhere down here. Don't have to know specifically where it is. Don't need to know the y-intercept, and so on. This is all we need. Okay, this is going to be enough to solve our inequality. Okay, so now that we have the picture, let's try to solve the inequality. Okay, this is the inequality we're trying to solve. Okay, Remember, it's not exactly like the one we were given. It is equivalent to x times x plus 1 is greater than 12, but we multiplied everything out and moved the 12 over, and we just rearranged the inequality. Okay, this is easier to work with, so that's why we're working with this version of it. Okay, so remember, f of x, okay, that's the parabola we just graphed. F of x is x squared plus x minus 12. Okay, that's the left side of the inequality. Okay, so you can translate this as where is f of x, which is the parabola, where is it bigger than 0? Okay, and then you can translate this statement. F of x is the same thing as y. Where are the y values bigger than 0? Okay, well, we know that positive y values occur above the x-axis. Okay, so let's look at the portion of the parabola that is above the x-axis. It's these two purple segments. Okay, so those, if you take any point that is highlighted in purple, because these pieces are above the x-axis, the y value is going to be positive. That's what you want. Okay, so to write down the answer, you have to state the x values where the y values are positive. Okay, so we need to write down the x values that have positive y values. Okay, so these are the portions of the parabola above the x-axis. Okay, so we just need to go to each purple part and write down the x values over which this is happening. Okay, so basically, remember this parabola goes up, 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 up forever. Okay, so it's still covering all the negative x values, and then the parabola goes up, 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 up this way, so it's still covering all the x values bigger than 3. Okay, if you need to, think of vertical lines going through the x-intercepts. Okay, so if I draw in this red kind of dividing line, a vertical line through -4. Okay, and then I draw another one through +3. I'm just drawing kind of a partition between, well, I'm drawing a kind of a partition through these x-intercepts. So it basically divides your x-axis up into 3 parts. Okay, you've got all the x values less than -4. You've got all the x values in between -4 and +3. And then you've got all the x values bigger than 3. Okay, where are the purple segments? Well, they're over here. Okay, x values are less than -4. And then the other purple segment is where the x values are bigger than 3. Okay, those are the segments we want, the purple stuff. Okay, so to write down the answer, which is the x values where you have these purple segments, okay, this leftmost segment, like I said, it's all the x values less than -4. Okay, so from -infinity to -4. Okay, and then the rightmost purple segment is all the x values 3 or bigger. Okay, the question becomes, do you include the endpoints? Okay, and that is all dependent on the inequality symbol. The inequality symbol here is strictly greater than. Okay, so we need our, well, I guess we should look at this inequality symbol. We have greater than. Okay, so we need the y values to be strictly greater than 0. Okay, so you do not want to include the x-intercepts because they have coordinates, -4, 0 and 3, 0. Okay, their y coordinates are exactly 0. That's not what we want. We want y values bigger than 0. Okay, so we're going to use parentheses here. Okay, we have to consider both segments, so I'll put a union to join those two intervals, and that's your answer. Okay, so going back to the original inequality, okay, remember at the beginning of the video, I gave you the example of x equals 0 and we plugged it in and we got 0 is greater than 12, which is false. So we said 0 was not a solution to this inequality. And look at our solution set. Okay, all numbers, the x values that you have to plug in to make this a true statement, those are the x values that are less than -4 or bigger than 3. 0 is not in the solution set, okay? Because when you plug it in, you get a false statement, okay? So it agrees with what we initially observed, okay? So that is how, in a nutshell, you do these quadratic inequalities, okay? Let me recap. You need to first take your original inequality and rewrite it. You need to multiply everything out, move everything to one side so that one side is 0. And again, it is recommended so that you move things around so the x squared term stays positive, okay? You need to realize whether the parabola opens up or down. The parabola you're looking at is the non-zero side of the rewritten inequality, okay? So once you establish whether it opens up or down, you need to either factor or use the quadratic formula to get the x-intercepts, and then you make a rough sketch, okay? You need to graph the x-intercepts in order, and then you need to draw your parabola going through them, either opening up or down, okay? And then the solution set you're going to be analyzing. Depending on your inequality symbol, you need to be looking above the x-axis or below the x-axis, okay? And then you just write down the corresponding x values that meet the criteria you're looking for, okay? Let's try another one.